Welcome back for the second tutorial. I am Orville Cota presenting to you all PCB designing using KiCad. For the first tutorial, we already created a schematic view. Now we did the electric rule check. Now let's go to the second part where we give the actual dimensions for the components. So before we go into the next part, we generate a netlist. Click on it, netlist, then save your project. It's saved. A netlist is created. Now we go to the second phase, which is PCB or component modules, where we give the dimensions. And open. You can see all the components that you used are presented over here. The C1, that is capacitor, diodes, connector P1, connector P2, and the resistor. Over here we are using a capacitor, that is a ceramic one. Click over here, give for C. You have the ceramic capacitors. If you want to see them in a 3D view, you can see them. Go to 3D. See the slanting one. If you prefer this, you can use it. But I would prefer standing one, which is this one. There you see, it's in the 3D view, it's a straight standing one. So now measurements always in millimeter. Check the grid. What is the grid? 1.27. I want to measure the distance between these two pins. Let's measure it. Keep on one of the grid points. Use your arrow key. 1, 2, 3, 4. There you have 4. So use a calculator. If 4 multiplied by the grid is 1.27. Enter. It is 5 millimeters. 5 millimeters is just perfect for us. So we use it. We just double click to enter there. Next value is automatically selected. Diodes. For diodes, just click D. See, there are different types of diodes. The first one, let's check how it is. Okay, we'll check it in the 3D view. Yeah, this is the one that we require, but we'll check the measurements always in millimeter. The grid 1.27. Let's check the distance between the two pins. Place on it, use your mouse. 1, 2, 3, 4, 5, 6. That is 6. Again 8 millimeters. So it's good for us. We can use it. Double click. The next one already selected. So again double click, double click, double click. Now P1. P1 is over here. That is the input one. For that, I'll go for something known as pin array. Give P. I'll go for pin array 2 cross 1. We'll see it in 3D how it looks. Yeah, with a positive and negative one. In 3D, it's a pin array with just pins. Since the input from the transformer, polarity is not considered. So just 2 pins are enough. The distance 1, 2. 2 into 1.27, which is nearly 3 millimeters, which is good enough. So I selected. For the second one, it's going to be a polarized, that is with a positive and a negative one, negative output. So I'll select something as cell 2. Insert in 3D. Yeah, it's 2 terminal device with a positive. A square represents a positive and a circle represents a negative. So the distance 1, 2, it's nearly 3 millimeters. It's good for us. So I selected. And the resistance, just give R, then R1, R3. So we just see what type of resistors are those. If you see, this is a standing type resistor. If you are comfortable with it, you can use it. But I would prefer using a resting one, that is, yeah, a resting capacitor. we see the dimensions, that is 1 2 3 4 5 6 8 millimeter, good enough. Double click and select that. Now all the component that we required with the actual dimensions we have given. The ground, it's in the terminal part, so we don't have to give a separate ground. Now what we do is we save it. It will ask for a place, the created folder will save it. That's it with the second part. For the third part, come back. Thank you. It's Orville Cota or www.orvillekota.webs.com.